Hello and welcome to our topic for today, which is physical quantities. Now, when we talk about quantities, physical quantities, we are talking about a number of things. But first, let's look at what physical quantities, or let's give examples of physical quantities. An example of a physical quantity can be speed, and I believe that all of you are aware of what speed is. You're also aware of distance. This is an example of physical quantities. So these two are examples of physical quantities. Now, what makes them unique is that they have the numerical magnitude. For example, this one can have a numerical magnitude of 20 meters per second, and the distance can have a numerical magnitude of 20 meters. Look, all of them have the same numerical magnitude, but now what differentiates the two is that for speed, we have 20 meters per second. However, for distance, we have 20 meters. So the numerical magnitude here is the same, but the unit is different. So the unit differentiates what distance is, and it also differentiates what distance is from speed. Now, one thing you should note that is that a physical quantity must have a numerical magnitude, just like we have mentioned that numerical magnitude is, for example, a letter word, for example, 20 meters or 30, 40, and so on. This is the numerical magnitude. However, the unit now is represented by meters per second, meters, okay, even we can have second and things like that. Now, you will also realize that in physics, every letter or every alphabet letter, or most of the Greek letters, are used to represent the physical quantities. We have a number of Greek letters, there are 26 in number. All those 26 letters are used to represent different units. Now, these letters, without any context, are meaningless. If they don't represent anything, they are meaningless. But however, we are using them to represent quantities or physical quantities in physics. Now, to represent a physical quantity, it must contain both numerical value and it must also have a unit in which it is measured. Like, for example, we have seen that distance is measured in meters, uh, speed is measured in meters per second. So those two are different because of the units that they have. However, they have the same numerical magnitude. Now, the letter V can be used to represent, for example, we can use the letter V to represent speed or velocity. Let me say velocity for this case. We can use the letter V to represent velocity. And remember the same letter V, we can also use it to represent volume. This is the same letter. We can also use the same letter V to represent voltage. So V can be used to represent three different quantities which have very distinct meaning from each other. For example, velocity is completely different from volume, and even they have different SI unit or different measurement unit. Volume also has the same uh, different unit as velocity, and voltage also has the same different unit as velocity. For example, this one we know it is measured in meters per second. Our volume is measured in meters per meters cubic. Uh, Voltage is measured in volts. So we know the various units that at which they are measured. Now, each and every physical quantities have their own representation. Now, there are important physics quantities that we learn in physics, and it is useful that you know these quantities. These are particularly useful when it comes to estimation, and a few examples are of useful physical quantities to memorize are given in the list that I'm just supposed to present. For example, we can talk about the diameter of an atom. We can talk about the wavelength of a light. We can talk about the height of a human adult. We can talk about the distance between the Earth and the Sun, mass of an hydrogen, mass of an adult human, mass of a car. Then we can also talk about seconds in a day, seconds in a year, the speed of sound in air, the power of light in a bulb, then the atmospheric pressure. Those are some of the estimates that are always required, students are always required to know. So that if you are given at any point that estimate the work energy required for an adult man to walk upright uh, on up a flight of stairs, you can always imagine that if the stairs, let's say, is 2 meters above, then you know that the mass of a human is about 70 kg, and you also have the gravity, which is 9.81. If you multiply these two, you will always get the energy. So these physical quantities are always required. And for any student who is sitting for AS level, please make sure you follow this channel for more guidance. Please log into my channel for more video that are to follow.